Picture this. A stone fortress rises out of dry earth. Walls 10 feet thick, no glass windows, just narrow slits cut into solid rock. Outside temperature, 40 degrees Celsius. The air does not move. The sun does not forgive. Now picture your modern home. Concrete, glass, sealed rooms, ceiling fans spinning at full speed, maybe an air conditioner fighting to keep the room below 30. And when the power goes out for just 2 hours, the heat becomes unbearable. The air turns heavy. You start sweating without moving. In 1293, inside the inner chambers of Croix de Chevaliers, temperatures remained close to 22 to 24 degrees Celsius, even during peak summer heat. No electricity, no air conditioning, no mechanical ventilation. Hundreds of people were inside, staying cool, while outside the stone itself was hot enough to burn your hand. How is that possible? What did medieval builders understand about heat that we have completely ignored? Walk through a modern building site today, and you will see what we call advanced design. Concrete slabs, reinforced steel, glass panels, flat roofs, sealed interiors. Everything is designed to resist the outside. But here is what thermal measurements reveal. Modern buildings do not just let heat in, they trap it. Glass amplifies solar radiation. Concrete absorbs heat rapidly, but releases it inward. Poor ventilation locks hot air inside. Your house becomes a heat container. The average modern concrete home exposed to 40 degrees Celsius. External temperature can reach 35 degrees Celsius indoors within hours without active cooling. The fundamental problem is not insulation. It is heat storage and release timing. Modern buildings absorb heat fast and release it fast in the wrong direction. Medieval castles did the opposite. They absorbed heat slowly, stored it, and released it when it no longer mattered. The foundation of medieval cooling was not technology, it was mass. Castle walls ranged from 8 to 15 feet thick and were built from limestone, sandstone, or granite. A single section of wall could weigh over 15,000 kilograms. Stone has extremely high thermal inertia. It takes hours, sometimes an entire day, for heat to penetrate fully through it. So when the sun hits the outer wall at noon, the heat does not reach the interior until late evening or even midnight. By that time, the outside air is already cooling. The heat arrives when it can dissipate harmlessly. This delay is called thermal lag. In massive stone structures, thermal lag can exceed 10 to 12 hours. That means peak daytime heat never actually enters the living space during the day. It arrives too late to matter. Compare that to modern walls. Concrete panels, brick veneers, thin plaster layers. Thermal lag may be 1 to 2 hours. So when the sun hits your wall at noon, you feel it inside by 2 p.m., exactly when you do not want it. Medieval builders were not trying to stop heat. They were controlling when it moved, and timing was everything. But walls alone were not enough. Look at the windows. In castles, windows were narrow, deeply recessed into thick walls, sometimes just a slit. This was not just for defense. It minimized direct sunlight entering the interior. Sunlight is not just light, it is energy. Once it enters a room, it converts into heat and gets trapped. Modern buildings maximize windows with glass from floor to ceiling, open views, and abundant natural lighting. Every square meter of glass can let in up to 800 watts of solar energy under direct sun. That is like running multiple heaters inside your room all day. Medieval architecture did the opposite. Less light meant less heat, and what little light entered had to pass through deep stone channels, losing energy along the way. Then there is airflow. Modern homes rely on fans and air conditioners. Remove them and airflow collapses. But medieval castles were designed to breathe. They had high ceilings, large halls, and vertical shafts. Hot air rises. This is basic physics. Castles used it intentionally. As hot air accumulated, it moved upward into towers, vaults, and upper chambers. Small vents and openings at higher levels allowed that heat to escape. This created natural convection. Cool air was pulled in from lower openings, replacing the rising hot air. No machines, just pressure differences and gravity. In places like Alhambra, this principle was refined even further. Air did not just move, it was guided. Courtyards acted as cooling centers. Water channels ran through living areas. As air passed over water, evaporation reduced its temperature. Even a small drop, 2 to 3 degrees, changes how the body feels. Evaporative cooling, simple, passive, effective. Now compare that to a sealed modern apartment. No airflow, no pressure exchange. Heat enters and stays. The building becomes a closed system. Closed systems accumulate heat. Medieval castles avoided that completely. They were open systems, always exchanging air and always moving heat out. Even the floors played a role. Stone floors stayed cool because they were in contact with the ground. Below a certain depth, the earth maintains a stable temperature, often around 15 to 18 degrees Celsius, depending on region. This is called ground coupling. Castle floors acted like natural heat sinks. They absorbed excess heat from the air and transferred it into the ground. You can still feel this today. Walk barefoot on stone and it feels cold even in summer. That is not because the stone is cold. It is because the stone is pulling heat away from your body. Now imagine an entire building doing that constantly, pulling heat down while pushing hot air up. A vertical heat extraction system built with nothing but stone and geometry. And then there is layout. Medieval castles were not open plan. Rooms were segmented. Corridors were narrow. Doorways were controlled. Why? Because smaller spaces are easier to regulate. Heat spreads slower. Airflow can be directed. In modern homes, large open spaces allow heat to distribute instantly. One hot room becomes the entire house. In a castle, heat stayed localized. Some rooms were intentionally placed on the north side and never received direct sunlight. These became summer chambers. Cool zones, places where, even during extreme heat, temperatures remained manageable. Historical records from Middle Eastern fortresses describe rulers moving between rooms based on time of day, following shade and airflow and thermal conditions. The building wasn't static. It was used dynamically. Now consider the roof. Modern roofs absorb enormous solar energy. Flat concrete roofs can reach 60 to 70 degrees Celsius under direct sun. That heat radiates downward into living spaces. Medieval castles often had layered roofing systems, stone vaults beneath, sometimes covered by additional materials above. Air gaps between layers reduced heat transfer. Some designs allowed hot air to escape through upper vents before it reached interior ceilings. Again, controlling movement, not blocking it. Everything comes back to the same principle. Medieval builders did not fight heat directly. They redirected it. They delayed it. They ventilated it. They absorbed it. They released it when it no longer mattered. Modern buildings try to block heat completely, and when that fails, they rely on machines to fix the problem. But machines require power, and when that power disappears, so does comfort. The brutal reality is this. A modern house in 40 degrees Celsius heat without air conditioning becomes unlivable within hours. A medieval castle without any technology remains stable, not perfectly cool, but survivable, functional, controlled, because it works with physics instead of against it. And the deeper you look, the more uncomfortable the question becomes. Did we actually improve building design, or did we just replace understanding with energy consumption? If medieval castles stayed cool in extreme heat, why do we not build like that anymore? The answer is not ignorance, it is trade-offs. Start with cost. A castle wall 10 feet thick is not just material, it is time, labor, logistics, quarrying stone, transporting it, cutting it, laying it. One section of wall could take weeks. An entire structure could take decades. Modern construction compresses that into months. Concrete can be poured in a day. Steel frames go up in weeks. Entire buildings are completed before a medieval foundation would even be finished. Speed replaced permanence. But speed comes with consequences. When you reduce wall thickness, you reduce thermal mass. When you reduce thermal mass, you lose control over heat timing. And once that control is gone, you need machines to compensate. Air conditioning is not a luxury. It is a requirement for the way we build now. Then there is space. Medieval design was not optimized for comfort in the modern sense. Windows were small, interiors were dim, airflow paths were deliberate, not always convenient. You did not get panoramic views. You got survival. Modern architecture prioritizes openness. Light, visibility, glass walls, open layouts, high exposure. But every design choice that increases comfort visually often increases heat gain physically. So the building looks better, but it performs worse. And then there is urban density. Castles were isolated. They had space around them. Air could move freely. Heat could dissipate into open land. Now look at a modern city. Concrete stacked on concrete. Buildings trapping each other's heat. Streets radiating stored solar energy long after sunset. This is the urban heat island effect. In dense areas, nighttime temperatures can remain 5 to 10 degrees higher than surrounding regions. That breaks one of the key advantages medieval structures relied on. Cooling at night. If the outside air never cools, thermal lag becomes less effective. The system starts to fail. And yet, some of these principles never disappeared. They were just reduced. Look at traditional homes in hot climates. In parts of Yemen, tower houses built centuries ago still use thick earthen walls. In Morocco, riads are built around internal courtyards with water features. In Iran, wind catchers, called badgers, pull cool air down into buildings while pushing hot air out. These are not historical accidents. They are engineered responses to heat without electricity. The same physics, the same logic, just adapted to different environments. Even today, architects are quietly rediscovering these ideas. Passive cooling, thermal mass, cross ventilation, shading geometry. But here's the difference. Modern systems try to add these features onto lightweight structures. Medieval builders made them the structure. It was not an addition, it was the foundation. And that changes everything, because passive systems only work when the entire building supports them. A single thick wall in an otherwise thin structure does nothing. A small vent in a sealed building changes nothing. These systems require integration. They require design discipline, and most importantly, they require accepting limitations. Less glass, Thicker walls, smaller openings, more material, more time. And in a world driven by speed, cost efficiency, and aesthetics, those are difficult compromises. So instead, we choose control. We install air conditioners. We increase power supply. We solve the symptom, not the structure. And for now, it works. Until it does not. Power outages, energy shortages, rising temperatures. Each one exposes the same weakness. Our buildings do not regulate heat. They depend on systems that do. Remove the system, and the building fails. Medieval castles did not have that problem, because the building itself was the system. Not perfect, not comfortable by modern standards, but resilient, stable, predictable. And that might be the real difference. Modern design optimizes for ideal conditions. Medieval design prepared for worst-case scenarios. So when the temperature rises to 40 degrees Celsius, one structure adapts, the other struggles. And that raises a final question. As climates become more extreme, as energy becomes less predictable, as cities grow hotter, which approach actually makes more sense? Not historically, not aesthetically, but physically, because the laws of heat have not changed. Only the way we choose to deal with them has. Thank you for watching this video. Click here to watch another video that might interest you.